Hi everyone. In this video we are going to talk about a topic which creates a lot of confusion in our minds, and I thought I would create a video to clear this confusion forever. Now I have taken a couple of examples. You can see on the left hand side I have x squared is equal to 25, then x equals how much, and similarly on the right hand side I have square root of 25 equals how much, and negative square root of 25 is equal to how much, right? So let's first solve the example on the left hand side, and then we'll talk about the right hand side. Now in the left hand side, if you see the information that is provided here, x squared is equal to 25, that is actually an equation, right? That is an equation. It's a nice quadratic equation, and if we rewrite this equation, it's going to look like this. So it's going to look like x squared minus 25 equals 0, and that looks like a very simple quadratic equation. And let's try to solve this equation. So what we're going to do? Well, we'll try to factorize it, and this is x times x minus 5 is equal to 0. From here, if we equate each factor to 0, then we will get a value of x. So this is going to give us x equals negative 5, and the other one will give us x minus 5 equals 0. That would give us x as positive 5. So we have found the two values of x, the negative 5 or positive 5. So in this case we can say, okay, the solution has two values. The values are positive 5 and negative 5, or if we combine them together, we can say that x is equal to plus or minus 5. So that's the combined picture of the solution. So that example was actually a quadratic equation, and we could easily solve it to find the two possible values of x, right? Now let's look at the example on the right hand side. Now if somebody gives you a number like this, and let me erase this portion. Suppose here is a number, right? The number has been written like this, and we want to know what exactly it is. Now in your mind, if you're thinking that, well, square root of 25, that also can be written as like plus or minus 5. Can we write it like that? Can we say it like that? Actually not, because we have to first understand the definition of a square root like this, because in this example it is not an equation. In this example what we have is actually a number. I am highlighting this, the square root of 25, that is not an equation, that's a number. That's just a plain simple number. And whenever you have a number like this, from the definition of square root, we have to take the principal square root value. The principal square root value means the two possible values that we have written right here, the positive 5 or the negative 5. Let me write it here. So from here we can say, okay, the two possible values that we are looking at, one of them is positive 5 and the other one is negative 5. Now which one is the principal square root value? Well, this is the principal square root value. I'm going to highlight it. This is the principal square root value. Whichever is the higher value, that's the value we need to take. So for that particular example where we have square root of 25, we need to take positive 5 as the value of that square root. So we can say, let me erase this portion for now. I'll come back to it again. So here we can say, okay, this will be equal to positive 5 or simple 5, or you can write it as positive 5 or just 5. That will be the correct answer. That will be the correct answer. So square root of 25 is not plus or minus 5. It is just plus 5 or positive 5 or just 5, which is a positive number, right? So we need to take the principal square root value, and the principal value is the higher of the two possible values, and the higher value obviously will be the positive value, not the negative value, and that is called the principal square root value. So let me make a note here. Alright, now let's talk about the negative square root of 25. So now we are going to talk about this number, negative then square root of 25. Right? So again, when you have a number like this, you first want to focus on this portion. You need to focus on this portion. Forget about the negative sign outside, right? That's just a negative 1. So we can write it as negative 1 times square root of 25. And I'm keeping the negative 1 as is. Now we want to focus on this square root of 25, and we have already explained what should be the value for square root of 25, and that is going to be positive 5. We cannot take the negative 5, we have to take the positive 5, because again in this example also we are not talking about equation, we are talking about a number, and the number is square root of 25. Oh, by the way, we have a negative sign outside, that's okay, but the square root portion is nothing but a number. It's just a number, and we have to take the principal square root value, and the principal square root value would be a positive 5. So we can say, in this case we can say, okay, this must be then We already have a negative 1 outside, that's okay, but for this one we are going to write it as positive 5 because square root of 25 is actually positive 5. It's not negative 5, it is positive 5, which is the principal value of the square root. So then our answer would be, well, negative 1 times 5, that would be negative 5. So that is our answer. So for the second example, that is our answer. When it is negative of square root of 25, that will be negative 5. However, if you have simply square root of 25, that will be a positive 5. And let me highlight that also. I hope it is clear up to this point. Now, in the same context, if we have to talk about square root of x squared, so just keeping that in mind, now I'm going to give you one more example. Let's say square root of x squared. When we had square root of 25, we knew that it was a square root of 5 squared, right? 25 is nothing but 5 squared. So square root of 25 is actually square root of 5 squared, and in that case, we knew that we needed to take the positive 5 instead of negative 5, or instead of both, we needed to take the principal value, which is the higher of the two possible values. But when somebody says square root of x squared, and it's like a variable, and we really don't know what is the principal value here. We know that it will be some form of x, but ultimately we want to take the positive value. But again, we don't know whether x is positive or negative. Think about it. X is a variable and we don't know whether x is positive or negative, but ultimately we know that the square root of x squared, this particular radical or the value of this radical has to be a positive value or positive number, right? Now, how do we ensure a positive number when we don't even know what the value of that variable is? We have to use the modulus function, which is the absolute value function. So we are going to say, hey, you know what, because I don't know whether x is positive or negative, to be on the safe side, I'm just going to use the absolute value function so that I can guarantee that its value will become positive, meaning we are going to get the principal square root value. So to ensure that we are using the principal square root value, we need to use the absolute value function or the modulus function to indicate that, hey, this is our principal value. And it is extremely important to remember because you are going to probably need it when you are doing limits and calculus. This thing comes up so often that you clearly need to remember that square root of x squared is not just x. It is absolute value of x or modulus of x. This is extremely important. I have put 2 stars on both sides. Please remember this, or please make a note of this, that square root of x squared, when you don't know what kind of value it has, whether it has a positive or negative, when you don't know, but ultimately you want to get the positive value, so then the only option here is to use the absolute value function. I hope it is clear up to this point. Now let's take the last example here, or rather one other scenario here, which is like this. So suppose somebody gives you that square root of a. If somebody says, hey, can I do like this, square root of a times square root of b is equal to square root of ab. Can I do it like this? Well, we can, but with a certain condition, and the condition is that both a and b cannot be negative at the same time. If that condition is true, then yes, we can combine them like this. So let me write down the condition here first. And that is the required condition, that both a and b are not negative at the same time. If one of them is negative, that is also okay. If both of them are positive, that's also okay. But if both of them are negative, then there is a problem and we cannot combine them like this. Now I'm going to show you with an example. So suppose let's take this example. Let's say we have square root of 2 times square root of 3. That is equal to, both of them are positive. So we can say, okay, this will be square root of 2 times 3. Which is nothing but square root of 6. Now, if somebody takes another example, say, hey, suppose now I'm going to take both of them negative. So if we take both of them negative, and it will be like this, so we can say, okay, square root of negative 2 times square root of negative 3. Can we do it like this? Here is one of the ways. I'm just going to mark it as the first way, and then finally we'll talk about it. But let me first do it and see what I'm doing here. So if you have it like this, then can you want to say it like this? You want to say, okay, then we can do it like this. If we could do it like this, then it's going to look like this, which would be again square root of 6. And then here comes the other way. Another person says, okay, you know what, I'm going to do it the other way. Let me do it in a different way. And how is that? Let's see. So suppose the second person says, okay, you know what, you give me square root of negative 2 times square root of negative 3. And what I'm going to do, I'm going to do them like this, or I'm going to break them like this. So this is negative 1 times positive 2. And then square root of negative 1 times positive 3. And then from here, so the person says, okay, now I have a square root of negative 1 times square root of 2 times again another square root of negative 1 times square root of 3. So from here, what do we get? we get square root of negative 1 times square root of negative 1 and then times square root of 2 times square root of 3. And can we write it like this? Well, this is nothing but square root of negative 1 squared, because we have two of them being multiplied here, and then times square root of 2 times 3. And from here we can say, okay, square root of negative 1 squared, that is actually negative 1, times square root of 6. So this now becomes negative square root of 6. Now look at these two values. We have one person said, well, I'm going to do it my way, and that gives me positive square root of 6. And then another person says, well, I'm going to do it my other way, and that gives me negative square root of 6. So what is the correct value then? Or what is the correct way of combining them, right? Well, the first way, you see that each of the components there, like right here, each of them had a square root of negative 1 inside, which is like the imaginary number iota, right? So each of them had a square root of negative 1, and that was easily ignored. That was conveniently ignored when both the square roots are combined like this. We lost the square root of negative 1 and square root of negative 1 from both the factors. So we lost that information, and that is why this is incorrect. This is wrong. However, if you look at the second way, there the negative 1 has been preserved. We did not ignore it. We kept it. Finally, we came to the answer, which is negative square root of 6, and this is the correct answer. Why? Because when you combine two negative numbers, like if you see up there, if you look at the condition there that both a and b are not negative at the same time. Now, what if they are negative? Well, if they are negative, then we have to combine them this second way. We simply cannot combine them like the first way. We have to combine them the second way. We have to make sure that we do not compromise the square root of negative 1. We have to make sure that we take care of the square root of negative 1 without simply ignoring it, right? So the second way is the correct way when you have both numbers inside the square root when both of them are negative. When your square root of a times square root of b, when a and b both are negative, we have to make sure that we do not conveniently ignore the square root of negative 1 which is hiding in there. So we have to preserve that, and if we preserve it, finally we are going to get a negative value like this, and that is the correct way of doing it. But if you simply want to combine them, you have to make sure that not both of them are negative at the same time. If one of them is negative, that's okay, but both of them cannot be negative, because then what happens when you multiply a negative by another negative number, it becomes a positive number, and we essentially lose the square root of negative 1 squared, right? I hope it makes sense. Thank you for watching. See you in the next video.